All right, let's redo this lecture. There was some technical difficulties in class, but basically we were trying to find a confidence interval uh, for the population, which we're going to call p hat. So, assuming you have this information, you can get the estimate by dividing x over n, where x is the trials or individuals in the sample, n is the total sample size. Now, using different alphas will get you different levels of confidence. What I was trying to calculate in class was this formula here. So you can find an interval for p by getting p hat, adding this stuff, and then what's it called? And then getting p hat, subtracting that same value. So what I'm going to do in Excel is calculate uh, this piece right here, and then just subtract it from the p hat that we already had using the example on Excel. And then adding it to p hat, and you have the upper bound. So this is the upper bound and lower bound, which will be an interval. Okay, so let's go ahead and do that real quick. Shorten the video up. Okay, so in this example, we had 800 randomly selected 16 to 17-year-olds. We found that out of those 800, 272 replied saying, yeah, they did text while driving. They wanted us to find a confidence interval for p hat, basically. Obtain 95% confidence interval. So if they want 95%, then you should choose an alpha of 0.05. This is the assumption that you have to make. So if they say 95%, change to 0.05. N is a sample size. X is the 272. P hat is x divided by n, the estimate, right? Q, or 1 minus P, is 1 minus P has 0.66, okay? Standard deviation, I gave this to you last week. It's the square root of P times 1 minus P, which is 0.47. So you're going to need these values to calculate the CI, okay? So confidence interval. So the function that you're going to use, I didn't have this, I was having some issues in class, but here works now, I think. To do confidence norm, and then they want an alpha, so type in the 0.05, which is based on the 95%, comma, standard deviation. This wasn't given, so you have to calculate this. This is square root of p times 1 minus p, and then the size of 800. So this is the value you're going to add and subtract to p hat. Remember we said, let's go back to the notes here. P hat plus this number, the number we just found is at 0.33. Okay, so switch back. Okay, so right here, to find the lower bound, you say p hat minus, oops, I'm going to put an equal sign, p hat minus this, and then p hat plus this. So there's my confidence interval. So from let's call this something else, value. So the actual interval is going to be 0. Let's just round it, 307, comma 0.372. So basically what we're saying is p hat is somewhere between 0.307 and 371. So that's how you calculate it. So you need standard deviation and you need p hat. And to get standard deviation, you need 1 minus p. Okay. But that's it. That was what wasn't coming out earlier. Sorry about that. Let me post this in just a moment. But first, let's look at the homework, see if I missed anything. Okay, let's see. So the first few are definitions, no big deal. Okay, put the following in order. Yeah, here we just gotta look at the formulas and see how that changes. To put the following in order from show the answer. From narrowest to widest interval. So 86%. So the less confidence, remember we said, um, would be the narrowest. So if we want to be super sure, then that means you're looking at the value within a small interval. So D would be the, let's see here, narrowest to widest. CAB. Oh, whoops. Okay. Yeah, so anyway, I got lost in thought there. The lower the percentage, the narrower the interval. Narrow, yeah, there it is. Okay. If they give you the p hat, which is 0.69, which of the following could be 90%? So here you can use the formula that I gave you, or you can plug this into Excel. So you would plug in p hat is 0.69, find the 1 minus p, and you would plug all this into here. So if we were to do another example, let's see here, let's do one with the answer. Yeah, we got that. Okay, we'll just copy all this to a new question down here. Okay, so when do we have n? Okay. All right, let's look at number 5. Here they're giving you the lower bound and upper bound and n, but they're not giving us x. They want us to solve for the point estimate, p hat, and the margin of error. So what we can do is use a formula. Here it's in the example. I'm gonna give it, I'm gonna let you guys look at this in the video because I didn't give it to you. Yeah, we'll use this one, that way you can see. Okay. So they gave us the upper bound, right? And lower and upper bounds here. So that means we can set these equal to p hat plus e. We don't have the error. So we can, since we have these two, you can add them together, divide by 2, and solve for this formula. So basically use this to find p hat. So the upper bound plus the lower divided by 2 will give you the center of the interval. So this, if these are the endpoints, this would be the midpoint, which is where p hat is. So that's another way to find it. So add them together, divide by 2, and that's it. Once you have that, use this formula here to find the error. That's pretty much it, though. Okay, now this one will be what I showed you on Excel, the example in the first example I did in this video is to calculate the lower and upper bounds using Excel. They use the distribution table here with the form. If you use the formulas they gave you, you would need the z-scores from here. But if you use the Excel file, just follow the steps I did earlier, and that should come right up with upper and lower. Okay, some more definition stuff. I'll let you do that one. Here are the requirements that I gave you at the end of the first formula. That's pretty much it. So that should be all you need. 5, I think, is a strange question. I'm probably gonna, well, I guess if you use those formulas, you'll be good. The ones I gave you earlier, or the one I showed you a moment ago. What was the weird one? Yeah, this one I'm probably gonna remove. Don't worry about 4. Anyway, there we go. I'll post this in just a moment.